Okay, so this video we're looking at plotting exponential graphs, which is the last on our kind of little mini series on plotting non-linear graphs. We've done quadratic graphs, and again, just to recap very quickly, quadratic is, the basic form is something y is equal to x squared, so the highest power is a square, and we get this kind of U shape. Or you could have something, again, where if it's minus x squared, it's going to be a reflection along the x-axis to look like this. So if we have y is equal to minus x squared, that is the most basic form of a quadratic. That's kind of like the sad face quadratics. We've seen that already. We've also looked at cubic graphs, okay, and this here is like this kind of S shape. The most basic form of a cubic is y is equal to x cubed again. And similarly, right, if we make it negative x cubed, well, it will look like this, which we discussed on that cubic video. So if it was y is equal to minus x cubed, okay, we kind of just reflect it along the y-axis here to get this blue one. We've looked at reciprocal graphs, reciprocal meaning 1 over something, in this case x, right, in the most basic form, and if we put it equal to y, it produces this graph that looks like this. Okay, and finally, we're on to quite a nice graph, which is the exponential graph, okay, and this is the most basic form of an exponential, okay, and we could say something like the most basic form of an exponential is going to be something like this. So y is equal to some number a. That a could be anything. It could be number 2, 3, 4, whatever, to the power of x. But what's really important with this, right, because we're looking at plotting exponentials today, what's really important is being able to recognize, right, if I look on example 1, okay, it says complete the table of values and draw the graph of this, y is equal to 3 to the power of x. If you weren't told that this is an exponential graph, you need to be able to recognize, right, if you've got something to the power of x, okay, so like over here, it is some number, that a just represents any number, okay, any integer number to the power of x, okay, then we're looking at plotting an exponential. So this table of values should produce something that looks like this last graph here. It is different, right, to the powers over here. These powers are numbers. So a square, number 2, a cube, number 3. This time it is the power of x. So that power can change. Okay, it could be, for example, you could have a exponential in the form y is equal to 2 to the power of x, or you could have y is equal to 3 to the power of x. It could be any number, but the power is x. Okay? Right. Sorry, I think I missaid something there. Anyway, hopefully you get the idea of what I'm talking about here. Anyway, let's get into it. It says complete the table of values and draw the graph of y is equal to 3 to the power of x. Right, because my power is to x, right, I need to recognize, and it is going to be a graph that looks something like this. Okay, that's the rough shape of it. But I want to complete the table of values, so let's go and do that. It's just substituting in these x values, okay, into this up here, y equals 3 to the power of x. So let's do that one by one so we can see what is going on. The first one is x is equal to minus 2. Let's put it into our equation, which is y is equal to 3 to the power of x, and x is equal to minus 2. What does this really mean? Well, 3 to the power of minus 2, hopefully we know that if we have some number and we raise it to a negative power, so like minus n, where n is just a number, we take the reciprocal of that number, and the power it is raised to is n. So that is one of our grade 5 rules of indices. It just means if you have a negative power, you go 1 over, you take the reciprocal of your number, and you raise it to the power given. So here, negative power, we've got to go 1 over our number, which is 3, and we raise it to the power given, which is 2. Well, 3 squared is 9, so we're going to get 1 over 9. So when x is equal to negative 2, y is equal to 1 over 9. So 1 over 9 goes in there. And let's do the same thing with x being equal to negative 1. So when x is equal to minus 1, we put it into our equation. Y is equal to 3 to the power of x, where x is now negative 1. Again, using our grade 5 laws of indices, negative power, we take the reciprocal, so 1 over your number, which is 3, to the power given, which is 1. Or 3 to the power of 1 is just equal to 3. So 1 over 3, 1/3. When x is equal to minus 1, the y value is a third. When x is equal to 0, this time, so when x is equal to 0, we get y being equal to 3 to the power of 0, and we need to know also another rule of indices is if we have some number, so I've just called it a to the power of 0, okay, it is always equal to 1. So any number to the power of 0 is always equal to 1. So 3 to the power of 0 is just 1. Okay, we keep going. If x is equal to 1, so when x is equal to 1, we put it into our equation, so y is going to be 3 to the power of x is now 1, well 3 to the power of 1 is just 3. So let's go and put that in there. And finally, when x is equal to 2, we put it into our equation. So 3 to the power, x is now 2, so 3 squared, which is equal to 9, is our final value. And then, like in the previous 3 videos, we just go and plot these points here as coordinates onto our x, y coordinate axes. So when x is equal to -2, y is equal to 1/9, which is a bit of an awkward one, right? We can't plot it exactly because our scale isn't going to be that accurate, but 1/9 is pretty small, so somewhere down here. When x is equal to -1, we get a third a bit bigger, so something like that. This is a really important point. This is a really, really important point. I'm going to highlight it in blue. When x is equal to 0, we get our y value being equal to 1, which is going to be this point here. And that is a really important point because any exponential, okay, no matter what that number is there, it always passes through the points 0, 1, which is something just to bear in mind, okay? When x is equal to 1, y is equal to 3, there we go. When x is equal to 2, y is equal to 9, so we go up here. And then again, like in the previous 3 videos, because it is a non-linear graph, we draw the points together using a freehand. So we join the points together, and it's quite hard to do on my screen, but I'll try and do it to the best of my ability on this, and was pretty good. If we keep going up, sorry, this last one's going to be a bit tricky to do. We keep going up, that's pretty good. And that is it, right? I've plotted the points and I've drawn my graph, but just to talk about this a little bit further, right, you're kind of seeing here that as we are increasing these x values in the positive direction, we're getting this rapid growth. Okay, we call it an exponential growth. It is increasing exponentially, right, at a really, really fast rate. So really, we should keep continuing this curve going upwards, okay, and this would keep going on forever and ever. So as the x values get bigger, the y values increase at a faster and faster and faster rate, at an exponential rate. And similarly, right, as the x values, so these values here, get really, really small, so -1, -2, and we kept going, the y values would keep decreasing. So they would keep getting, smaller and smaller and smaller. Oh, what was going on there? That's really annoying. Sorry, they would keep getting smaller and smaller and smaller and smaller and smaller and smaller and smaller, but they would never, ever, ever touch the x-axis. So if we kept going with this, right, all the way over here, okay, and it shouldn't really going, but it looks like it's going up again. It shouldn't be. It should just be sort of, you know, getting really close to it. I'll do it again. So it should be getting really, really, really close to it, but never, ever, ever touches it. Okay, so when x gets really small and really negative, it approaches y being 0, but never touches it. So for example, right, if I go and just show you, if I put in a really small x value like -10, so that's going to be well over here somewhere in the distance, but if x was equal to -10, right, we would get y is equal to 3 to the power of -10, which is going to be 1 over 3 to the power of 10, which is going to be a number really, really, really close to 0. Okay, I haven't got my calculator with me, but it's going to be a tiny number, close to 0. In fact, your calculator probably would just say it is equal to 0. It isn't, okay, but we just kind of say it is approximately equal to 0. It's going to be like 0.000000, a number. It's going to be absolutely tiny, but it never touches the x-axis, or y is equal to 0. Okay, so that's important to note. So kind of like on the right hand side, on the positive values of x, it increases at this rapid growth. Okay, and we keep doing so forever and ever, like this. Okay, and similarly over here, as the x values get really, really small and really negative, it keeps getting really, the y values keep getting really, really small, but they never ever touch the x-axis. Okay, which is something just to bear in mind. Okay, let's look at a different example. This time we've got draw the graph of y is equal to 0.5 to the power of x. And again, when we get these draw the graph questions, we're kind of thinking, well, what kind of graph is this going to be? Is it a quadratic? No, it's not a quadratic because the power is not a square. Is it a cubic? No, because the power is not a 3. Is it a reciprocal? No, because it is not 1 over x, but it is exponential because I've got a power of x. This time, my number part is 0.5, which is fine. The graph will behave a little bit differently, but let's just go and plot the table of values and go from there. So this time, right, it says plot this graph of values of x between -2 and 2. They haven't given me a table of values like the previous example. I've got to go and construct this myself then. So x from -2 to 2. So if I go and draw a table of values, so x going from -2, -1, 0, 1, all the way up to 2. Okay, I can go and get my y corresponding value. So I'm just drawing my own table of values here, That's going to help me get my y values. And let's go and draw this going across. There we go. So we're going to put these x values into our equation up here to find the y values. I'm actually going to write this a little bit differently, just because I think it's easier to think about. 0.5 is the same thing as 1 over 2. So I'm going to rewrite this as y is equal to a half, okay, written as a fraction to the power of x. They mean exactly the same thing, but it's much easier to work with fractions than it is decimals, in my opinion. Okay, I think it's just the way it is. Right, so let's go and put these into our equation. So when x is equal to minus 2 to begin with, when x is equal to minus 2, we get y is equal to, I'm going to write it as a half, so 1 over 2 to the power of x, where x is equal to negative 2. And actually, this is a bit of a trickier one to comprehend, but we do know, right, a negative power, again, a negative power means you take the reciprocal, you go 1 over your number to that power. So the same rule as before. We've got a fraction, that's fine. So we just have to go 1 over the fraction, a half, to that power, which is 2. So we've got 1 over. A half squared means 1 over 2 times 1 over 2. You're timesing your number by itself. 1 times 1 is 1, 2 times 2 is 4. So we've got 1 over, a half squared is 1 over 4. And if you've got 1 over something, basically you just flip it over. So we're going to be getting 4 over 1, which is just the same thing as 4. If that confuses you, right, just think about this as being 1. Okay, so 1 divided by this bit here, a quarter. Right, and 1 means 1 over 1. It's the same thing. If you're dividing fractions, keep, change, and flip. So it would be keep the first one the same, change your sign, flip the second fraction. Right, 1 times 4 is 4. 1 times 1 is 1. Hence, we get 4. So that is a lot of detail there, but I think it's good to understand what is going on, because we could just put that into a calculator, which is fine, but it's always good to be able to manipulate numbers yourself and understand what is really going on behind the scenes. Anyway, so this time when x is equal to minus 2, our y value is equal to 4. That is our first one. When x is equal to negative 1, let's do the same thing again. I won't talk about it in as much detail, but hopefully it makes sense. So now y is equal to a half to the power of negative 1. So again, negative power means we're going 1 over your number, which is a fraction, that is fine, and you're raising it to the power that is given, which is just going to be 1. So it's just keeping that number as itself. So 1 over a half to the power of 1, it's just 1 over 2. And then we're just going to be, let's go to this, sorry, so we don't get confused. And then we're just, again, like just before here, if you've got 1 over something, you just flip it around. So 2 over 1, which is equal to 2. X is minus 1, y is equal to 2. And we keep going. When x is equal to 0, let's go and plug that in. So we get y is equal to 1 over 2 to the power of 0. And again, like the previous slide, right, any number to the power of 0 is just equal to 1. That's a grade 5 law of identity that we need to know. So nice and easy, that one, equal to 1. And now, when x is equal to 1, let's see what happens. X is equal to 1, we get y is equal to 1 over 2 to the power of 1, okay, which is our new x value. So a half to the power of 1, or anything to the power of 1, just keeps the number as it is. So we get 1 over 2 in this one. And then finally, when x is equal to 2, we get y being equal to 1 over 2, 1 over 2 to the power of x, well, x is now 2. 1 over 2 squared, the same thing up here, means a half times a half, which is equal to 1 over 4. So we get 1 over 4 as our y value when x is equal to 2. So let's now go and plot these coordinates onto our coordinate axes and see how our graph looks. So when x is minus 2, y is 4, so something like this. X minus 1, y is 2. There we go. And importantly, again, that's a pretty key thing with exponentials. Whenever x is equal to 0, your y value is always equal to 1 when your exponential is just in this basic form. So y is equal to a number to the power of x. It will pass through the point 0, 1, which it does again here. So there we go. X is 1, y is a half, so something like that. X is 2, y is equal to a quarter, so something like that. Let's go and join these points together using a smooth freehand curve. Okay, there we go. And that is fine. Right, I've drawn my points together with a curve. But we know, right, from the first slide that an exponential, well, the one that was given on that slide was, it looks like this. We can see this is a similar case, but it's kind of going in the opposite direction. So, you know, we can kind of just think about it looking like this. Okay, I can kind of continue my graph here, right? I can just kind of continue that sketch and draw this going upwards like this, because as the x values in this case get really, really small, because my number part here is a fraction, it's like a flip of the previous example. So on this example, right, we had a number, which was a whole number to the power of x. Now I've got a fraction to the power of x. It just flips the way my exponential looks. So when my x values keep getting really, really small, okay, my y values get massive. So for example, if x was equal to, we use an x value being equal to -4, for example, right, when x is equal to -4, y would be equal to a half to the power of, sorry, of -4, right, which would be 1 over a half to the power of 4, right, which would be equal to 1 over 16, flip it over, which is equal to 16. You get a big y value, basically. Okay, so when x gets really, really small, your y values get massive. Okay, and similarly, as your x values get really, really big, okay, your graph will continue to get really, really close, right, to the x-axis, but it will never, ever, 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 ever quite touch it. It will get really close to it, but never touch it. Okay, so that's important to note there. So that is exponential graphs. We've now looked at all of the 4 different types of non-linear graphs that you need to know. So quadratics, basically where your highest power is a square. Cubics, where you've got a 3 in your equation as the highest power. Reciprocal, essentially 1 over x. And exponential, to the power of x. So you've got to be able to recognize what you're looking for and what the graph will produce. And that is it. Okay, hopefully that was a bit useful, and that is it for this video. Thank you.